So hello everyone, my name is Davidson, this is João. We are gonna talk about Bitcoin mobile clients. So a little bit of context. Last year we participated in a hackathon in Brazil called SatsHack, and we've presented a Bitcoin wallet that also had something called Floresta, which is a node-ish implementation. Uh, I will talk more about it in a few slides. And we won the hackathon, so that's cool. And we're gonna talk about our experience, what we found about running this kind of stuff in mobile phones. We run on Android. We tested on a very old Android, like a 2018 flagship. It's still like Snapdragon 835, so it's very old. And the smartphone was basically like, come on, bring more stuff, because it was basically nothing. No battery drain, no memory usage. Like, it was fine for the smartphone. But we did find a lot of trouble, especially the OS doesn't want us to do that. So we'll talk more about this experience, how can we maybe improve some of this stuff, and the possibilities that we found. So we talk about why this kind of thing is important, what's the difference between normal SPV and Floresta, and then we'll talk about the challenge we ran into when doing this kind of stuff. About us, so I'm Davidson. I work at Bitcoin open source at Vintium. I work on Utreexo and Floresta mainly. I have some contributors here and there, but mainly this. Here's my PGP key if anyone is interested, and my GitHub. And this is João.
Hello, I'm João. I'm a mobile developer, Belo Horizonte Beach Devs co-host. This is my GitHub, and I'm experienced on-chain and Lightning self-custodial applications.
So why mobile clients are important, you might think? Just buy a computer, right? Well, most people in the world use smartphones nowadays. It's like I put 50%, but that's a conservative estimate, and it's more like 60% of the world already have smartphones. Everyone has some kind of mobile device that they carry with. Because it became something like, it's basically like basic stuff that you need to live nowadays. People make all sort of crazy deals to buy smartphones. So in Brazil, it's customary to buy like a phone and pay 24 installments because you need a phone. A computer is not like that. So some people will not buy a computer just to run a node. And there's also all the trouble of setting up, like you have to run this, you have to run Electron server, you have to run core, you have to run some kind of NAT transversing software to access your node at home. This is like, nah, this is not something that most non-technical people are gonna do. And as a result, the number of full nodes, according to several websites that like count this stuff, is basically the same since 2017, about just like 100K nodes, and that's it, full nodes running. This number is stable for a long time, doesn't seem to increase a lot. And if you want Bitcoin to succeed, I truly believe that we need to have more people validating their own transactions, especially. I really think that Bitcoin validation should focus on your own transactions and also using it in a more private way, because if you don't have privacy, things are going to get ugly. So this is the problem we're trying to solve, like people validating their own transactions and in a more sovereign and private way. So unfortunately, it's kind of hard to use nodes. So basically summarizing this, ideally we would have some time. We can make trade-offs. We cannot do this. Like, we cannot run this on smartphones without making trade-offs. That is like pretty much a given. But we can make it better, like significantly better. So this is the word I've been working on with. Like, I don't want to make it perfect, because the perfect word doesn't exist, but I want to make it better. And the trade-offs that we are trying to make in Floresta are way better than we have nowadays. Nowadays, it's basically you connect to a centralized server, like an Electron server or Explorer server, and ask information for them, so they can log you, they can know exactly what you're doing, they can lie to you and pretend some payment went through when the payment didn't, so they can attack you. They can blacklist you. We saw an entire country in like altcoins, entire countries being kicked out of their network because like the US asked it, and the companies that serve this API infrastructure, they couldn't deal with those people, so they they cut the entire country out of their services. So this is not cool. We really want this to be like everyone can use independent of where do you live, especially because the countries that usually happen those stuff are the countries that need Bitcoin the most. So it's kind of bad. Regular SPVs are nice, but they are hard to get, right? So we basically don't have mobile SPV clients as far as I know. Like, it's not a thing that happens very often. They have some fragilities. They have some complications that you might be attacked. And we can really increase the 51% protection level that they have with some cool text that we can use. So next slide. What's the difference between Floresta and SPV? So Floresta has several different trust models that you can use. It's like very modular, and you can use it just like a full node. But before, what is Floresta? It's a lightweight client, so it works on any device, and it takes almost no resources. Just to give you a baseline, on mainnet, right now you use 300 megabytes of disk and 200 megabytes of RAM. So it's almost nothing. You use Utreexo and Prune by default. It's meant to be like the lighter client you can ever get in Bitcoin. And it's meant for non-technical people that just want to follow their own wallets. It's not for like hackers that want to index the blockchain or compute the price of Bitcoin based on Utreexo values. It's not that kind of public that we are looking for. It's more the layman who just want to follow their own wallet. It has an integrated watch-on wallet, so you can load your descriptor, your XPub, and it will follow your own transactions. You can find old transactions, use compact block filters. And it has an Electron server integrated, so you can connect your wallet to it out of the box without any additional setup. You just install Floresta, give it your XPubs, and you're fine. There is an extension in the Electron protocol that I've told them that would be nice, and apparently they are doing it. So if you implement any wallet, please check the, I think, 1.5 version of the Electron protocol, where you don't even need to give the XPubs. You just connect to the server, and the server can figure out everything else. But we need this change in the Electron protocol to go through. But then we have the biggest problem in UX when it comes, especially to mobiles, but everywhere, is called IBD, initial block download. Initial block download is hard to get for UX perspective. Even with new stuff like LibBitcoin that's getting IBD under 1 hour, that's still 1 hour. Like, most people won't just leave their phone running for 1 hour and like, I come back in 1 hour. No, I have to check my messages, I have to do stuff, I have to watch videos, and if the phone will get really hot, and all the problems we know. So what can you do about IBD specifically? But that it still has decent properties. We have two ways to do this in Floresta. One is assume Utreexo. It's basically assume UTXO for people who knows like Bitcoin Core, where you just give a commitment to the current, like the software that you're using gives you a commitment for the current UTXO set. But the difference is that it's Utreexo. So in Utreexo, the state, like the chain state, is so small that it fits on a QR code. It's like a few hundred bytes. That's it. That's all you need to start your node. And you can use, if you have like some friend or you are running a node on your computer, you can scan from the computer and move it to your phone as well. And the second one, which is more elaborated, is something called proof of work fraud proofs. As far as I know, Floresta is the first implementation of this. This was proposed in 2017, the mailing list by Robin Simpson. And it basically, it gives you the same level of security a full node would, as long as there is some minority of hash rate that's honest, you are not being SIBO attacked. So if those two premises hold, you will follow exactly the same chain as a full node. And the minority is hard to pin up on like a number because of variance, but we are working with greater than 95% majority. So someone to attack a client that implements proof of work fraud proofs need more than 95% of the hash rate. So it's like a pretty decent number, because with 95% of the hash rate, you can like activate soft forks, you can do all sort of stuff. So we kind of assume that this is impossible. Bitcoin would be in a very bad position if someone could get 95% of the hash rate. So as long as those two promises hold, you are fine. You'll follow the exact same chain as a full node, but in the happy case, you only download as many data as a normal SPV would, so megabytes. It's very lightweight, very easy to do. The mobile client will do this process in like minutes at most, depending on your internet, and then you are all set. And after that, after you did IBD, you validate everything. You are actually validating like a full node would. You download the blocks, you check if there is inflation, check if the signatures are good, you check if the outpoints are valid, you check everything, and you give the result back. And if the block is valid, then you accept to your chain. This is the users validate their own transaction part, because when you receive a transaction, you validate the block that this transaction is in, and you check the transaction is valid. We don't have mempool yet, but we will have mempool in, I believe, first semester of next year. So you will also be able to validate that. So this is Floresta. I hope it's clear enough the difference and the advantage.
So in the last year in SatsHack hackathon in Brazil, we developed the Floresta wallet. It's a mobile wallet that uses Floresta as chain source. It's capable of downloading and validating blocks, keeping track of user transactions, and even rescanning for holding transactions using CBF. It also spans foreground services that keep the node running when the app is in the background. I also created the Floresta node. It's a version with only the node features. You can load the descriptor to track your Bitcoin addresses. You can search transactions, and it provides an Electro server that you can use in all the wallets in your phone, so you don't have to depend on external services. This is the repo in case someone is interested. It's not on Google Store yet, but soon. Now, we found some challenges while developing mobile clients. The first one is the startup time. Some checks needs to be done on startup to make sure everything is in order. So we're starting the app too often may consume more system resources, especially battery. Background activity, Android runs activity when the app is in the background using Android services, but they be terminated if the device is running out of resources. And this can be result in database corruption due to ungraceful shutdowns. And we have more specific challenges for Lightning clients, like channel management. The user needs to pay for a channel and manage liquidity. And having a good UX for this is very difficult. The startup time, the node startup increases with commitments. Sometimes you have waiting for like 10 seconds to sync the wallet. And this may look like a long time for payment that should be instant. Delete and restore the app. The user may want to delete the app and restore it in the future. So ideally, the app should have the state saved on an external service to restore the channel. Multi-devices. The user may try to use the same Lightning wallet on multiple devices. This is normal for on-chain. But for Lightning, this will cause a state corruption and result on a forced close. And the last one is background payments. Lightning wallets only receive payments when the node is running. So if the run is running in the phone, it will only work if the app is online and the node is running. So as a workaround, we can use a silent push notification to wake up the app just to receive the payments, run the node to receive the payments. But it needs to be online and connected to backends to trigger. That's all. Thank you.
I have time for questions. If anyone want to ask anything.
So I have a question about the network activity before and after the initial block download. Do you notice that after IDB you actually have dramatically less network activity? Like, do you have any measurements?
Yeah, it decreases a lot because during IBD you are downloading stuff. For proof of work proof, you download the headers, so it's like 80 bytes per block. So it amounts to like a few megabytes, but after that, it can actually, if you get a lot of blocks in a sequence, it can actually be more because then you are downloading the whole block. So it's the whole full 1-2 megabytes of the block. So it depends on the network, but I would say yes. Just the main thing that you download afterwards is blocks. So it's like 144 blocks per day on average, times the size of those blocks. It can go up to 4 megabytes, so that's your usage per day of bandwidth. This is something we've actually been thinking about because it may not be great for like mobile, especially if it's like prepaid, because you're paying per gigabyte. I've made a napkin calculation once and it was like 4 gigs per month. This is like the standard plan in Brazil. So we don't want to waste all your plan in like your Bitcoin node. So we have some ideas like Android lets you know when you are on like the paid network and Wi-Fi. So we can have like an offline mode where the node's dormant for when you are on the mobile network, and then when you go to Wi-Fi, download stuff. So it's another challenging is networking, especially if you are on metered network.
And then what about for nodes that go offline for a little bit? Is there any challenges with it catching up?
You need to download and validate every block. Validate a few hundred blocks is fine, in my experience. If you stay out for more than like a couple of thousand blocks, you basically pretend you're doing IBD again. You do the proof of work cloud proof again because then it's too expensive computationally. Your phone will get really hot, so we don't want that. But a few hundred blocks is fine to catch up. Like a few days worth of blocks is fine to catch up.
Thank you.
Thanks. Yeah, really cool project. I had a question. You mentioned some of your new features. One would be mempool. I mean, like having access to the mempool. Wouldn't that be a lot of bandwidth from a mobile device? Or do you have some, I know there's, I think maybe mini sketch, or there's some techniques to shrink that?
Yeah, we are looking into mini sketch and set reconciliation for like airlay stuff. It's actually a trade-off because with compact block relay, we are actually doing something good for the device, because when a block comes in, you have to validate all those transactions in a batch. If you download them from mempool, you only validate them you validate them as they come. So they come like a few transactions per second. So you spread out the validation over a longer period of time, and when the block comes, you just like hash them to see which transactions are in the block. So I would say it's actually an improvement, especially when it comes to CPU usage, because your CPU usage is not like peaky, because that's bad for CPUs. It's better for you to use the CPU for more time, but in a lower power setting, than like for a little time, but higher setting. That's like where you use more energy. So I would say the mempool is good on that point, but yeah, definitely on the bandwidth side, especially without reconciliation, it can make the bandwidth side worse. So it's a trade-off, I guess, we need early.
So you're really thinking that the node will be running all the time on the device to be able to, or
that's a possibility. We've managed to do this using something called foreign ground services in iOS, on Android, sorry. Those are when the application has like a little notification that keeps there forever. That's a foreground service.
When you're playing a music, for example.
Yeah. Orbot, if you run Orbot, it stays with a notification that never lets you get them out. I think new Androids has a specific place for them now.
Had it on all the time when
they
can Wi-Fi, and otherwise not.
Then you can be notified of your transactions, for example.
Yeah.
If you receive a mempool transaction, we can notify the wallet. You don't need an external server to notify you.
The notification also has a stop button, so you can stop the node easily.
Yeah.
Neat. So I had a question also about your Lightning. What kind of Lightning implementation are you planning to incorporate there?
I'm working on BitKit that is using LDK node.
Hey, I think recently announced some work they're doing with async payments, which handles that offline scenario. So that might be something to look into.
Yeah. In Berlin, in Lightning++, we actually implemented with nLightning, the .NET implementation, and it was working fine, like out of the box. We could make them Floresta and nLightning talk. We could open Lightning channels. So I guess we have a path to integration. We need more support on both sides, basically.
Okay, cool. Thank you.
And for the Lightning people, wait until the video of my presentation comes out. I did a presentation on Utreexo and Lightning on Lightning++ last week in Berlin. So I guess it's an interesting thing to take a look.
No question. I just wanted to say you're doing God's work.
Thank you.